We're solving problem 16 from the 2024 F equals MA exam. A child of mass M holds on to the end of a massless rope of length L, which is attached to a pivot, a height h above the ground. The child is released from rest when the rope is straight and horizontal. At some point, the child lets go of the rope, flies through the air, and lands on the ground a horizontal distance d from the pivot. On Earth, the maximum possible value of d is dE. If the setup is moved to the moon, which has 1/6 the gravitational acceleration, what is the new maximum possible value of d? Now, right here, where potential energy has the highest point, kinetic energy has the lowest point, so we can equate them like so. Potential energy is equal to mg base E times the length L of the rope. And in case if you're wondering, this E stands for Earth, at least for what I'm concerned. And this is also equal to 1/2 mv squared. Solving for v, we get that v is equal to the square root of 2ge times L. Yes. Square root of that. Oh, and you have to specify this is on Earth. Because we're going to be moving to the moon soon enough. Now, the range of this projectile is going to be, well, distance, total distance is, this is v squared of E over g E. When you move to the moon, well, it says that it has 1/6 the gravitational acceleration. So we can do the same thing here. Potential energy, this is on the moon, mind ya. mgm for moon, L is equal to 1/2 mv squared, specify moon. Now the velocity on the moon is equal to the square root of 2 times g on Earth times L. Or, sorry, on the moon. Well, what is the g on the moon equal to? Well, that it says that's just the one. Well, on Earth, it has 6 times more the gravitational acceleration than on the moon. So therefore, we can do this by ge over 6. So velocity on the moon is equal to square root 2 times ge over 6 times our L here. Now, this is going to get interesting because we get that the velocity on the moon is equal in magnitude to the velocity on Earth over the square root of 6. This is interesting because then we can leak out this whole other equation. Distance on the moon is equal to velocity on the moon squared over the gravity on the moon. We can then plug this value of the velocity of the moon, dm, is equal to, well, this is ve over square root of 6 squared. And then we can plug this into Earth terms too, because we know that the gravitational acceleration on the moon is 1/6. It tells us. So this is ge over 6. So dm, the denominator, is going to be looking like de squared over 6. Therefore, when you simplify it, the new maximum possible value of d is simply dE, our answer for this problem.